My name is Adriano. I work for Google, and currently my focus is the Knative Productivity Working Group, together with Jessie and Srinivas. So, got back. In this presentation, I want to go a bit deep into the technical details of what the Knative Productivity Working Group do to achieve higher quality code and releases and other goals for the Knative project. So the agenda is pretty simple. I'll go briefly on what's Knative, what the Productivity Working Group does. Then I'll go deep into the architecture and details of how we do stuff on Knative to achieve the goals I just mentioned. I'll go through the life of a PR and a simple demo of what it means in the day-to-day work on Knative, and we'll have some time for Q&A. But before I continue, let me be pretty clear about what this presentation is. So this is not a presentation about Knative itself. We had several wonderful presentations about Knative in the previous days. So you have to refer to those if you want to know more about Knative. So I'm not going to be talking about what it's serving, what it does, or CRDs, or what the build pipeline does or could be used on the productivity. Not now, maybe in a future conference. This is also not about PROW. I'm going to talk a lot about PROW because we use that system. But if you want to know details about PROW, there was another session about it, and you can refer to that later if you want more details on how Kubernetes uses Kubernetes to run the Kubernetes flows. And finally, there was an intro session on Tuesday. My colleague Srinivas went through a lot of stuff we do in the Productivity Working Group, and my intention is to go deeper into what we do on the technical side in the Productivity Working Group. All right, so what's Knative? Knative is a Kubernetes-based platform providing primitives to help you easily deploy and manage your serverless workloads. In a nutshell, that's it. I'm not going deeper than that. Okay, we know what Knative is, pretty clear explanation. What the Productivity Working Group does. Our mission is to develop engineering guidelines, tools and infrastructure for Knative, and all those wonderful things that every software developer or company wants. High quality and high velocity deliverables, predictable releases, high collaboration, or high productivity. But why we need that for Knative? Because Knative is not a toy. We have 12 repos in the organization. We have more than 400 users, creating more than 160 PRs per week and filing more than 60 new issues per week. So we need to work on those seriously. We need to handle these things seriously. Okay, so how we do that on a technical side? This is the overall architecture of our system used to test and release Knative artifacts. In the center of everything is PROW. And together with GitHub and other tools like Test Grid, testing environments, tools like Kubernetes, and storage systems, we create the entire framework used for tests and release. I'm going to go through all the components one by one and what we do and how they apply to the overall case. So starting with the basics, our CICD system is PROW. It basically provides all the basic things we want on our CICD system. We want pre-submit tests, and those are required for merging our PRs. We want automatic merging. So, oh, the PR was approved. The PR didn't break anything, so why not merging it? We want continuous integration flows, even less than 1 hour or maybe 2 hours. It depends on the needs. We want nightly release. We want code coverage reports, and even going beyond code coverage. We want playground, so we can test the latest and greatest releases of Knative without having to bring up clusters and setting up a lot of stuff. We want just a single command line to start playing with that. We want to run performance tests to ensure that things are running smoothly as we wish. So given these basics, a lot of things can be already configured using prow. So our prow config will set one job for each pre-submit test, so we can run the pre-submit jobs in parallel. We want those pre-submit jobs to be required checks in GitHub, so you cannot submit or you cannot merge a PR if the tests are not passing. We want periodic jobs because we want daily runs of something, or nightly runs, or weekly. But we might want to collect data. We might want to run tests. We might want to do releases in a periodic fashion. We want to define approvers and reviewers, and that is done through the owner's files in the repos. So we set responsibilities and we set permissions to approve or deny PRs to be merged, or to even start tests on our system. And to achieve that, we have two important services in prow. One is Tide, that handles the automatic merging. It basically looks for reviews and approvals from repository owners that, together with passing tests, means, okay, this PR is good, it can be merged. Done, without manual intervention. And the other service is Boscos, which is a pool of GCP projects that are used for our end-to-end tests, ensuring that we have isolated environments, and not only isolated, but also fresh, so we can run tests without interference. So get a project, an exclusive project, run your test, bring up a cluster, run your test, shut it down, done. Next time, do it all again. You ensure that no external environment change will affect your tasks. And as a bonus, once we configure prow, we get a PR dashboard. The Kubernetes PR dashboard is a dashboard showing what you need to do on GitHub. It has a simple state machine that takes care of PRs that where you were assigned or you were called attention to. And makes your life easier to manage PRs when working on multiple repos on GitHub. Comes for free. Okay, and where does all this configuration and stuff live? In a separate repo, we call it test infra, and we keep the configurations there. We keep the tools we use for the test infrastructure there. We have shared code for the test starters. In our case, the frameworks in Go are in a different repo. So usually tests use shared code from 2 different repos, but that was a project choice. In this repo, we also maintain test-related tools that are kind of invisible to whatever repo is using our processes and tools. And this repo is a vendor in each Knative repo. So the good thing about it is that it's vendored, so you avoid breakages when you make changes to the repo. But the bad thing is that each time you have a new update, you have to replicate that to each other repo. In this case, one change in the test infra repo means replicating that to 11 other repos. And what about our tests? We have at least 3 types of tests: build tests, unit tests, and integration tests. No big deal here. We have the starter or the runners as helpers in test infra, so they are vendored and basically invisible to the other repos. They do all the magic, while the other repos just worry about specific testing code. Those tests, they have to run both locally or on prod the same way. So you don't have different way of running in one environment or the other. So it's easy to replicate failures. Finally, the integration tests, because they are the most complicated ones, we use kubetest to provide the Kubernetes cluster. Kubetest was developed by the Kubernetes team to test Kubernetes. But it can be used to test other stuff that runs on Kubernetes. So we are using it to easily bring up a test cluster and then shut it down after the test finishes for Knative. We also have conformance tests. These are a special class of end-to-end tests because they basically validate if the Knative implementation is following the contract defining the APIs. They have a separate display, although they are end-to-end tests, and I'll mention that later about the display. They have a separate display because it's easier to track how the conformance is going instead of mining the results into more than 300 tests we run. And finally, because integration tests tend to be, if not too many, too slow, they can be split when you run them on prod. So they run in parallel, and so the overall runtime goes down. We already have that for Knative serving. We run the integration tests and the upgrade, downgrade tests in parallel. Another important information we want is coverage. For code coverage, there's no support on prod yet. There is work in progress, but there's no ready-to-use solution. So we developed a custom tool for that use separate jobs in prod to report the code coverage either on a PR or on a daily basis. So that's an example of code coverage when you add a commit to a pull request. I'll mention more about that later. For runtime coverage support, and namely we're talking about latency and API coverage in our case, we have special logs in the continuous integration flow. Instead of having another job to run the test just to collect metrics, we piggyback on the continuous integration flow and fetch the metrics to display them. We use Test Grid as the one-stop shop for displaying all the coverage and health metrics for Knative. That's an example of the latency grid for the tests. About the pre-submits, I mentioned that we have separate jobs for running the tests and that they are required status check on GitHub. Again, meaning that you can't merge a PR if the tests are not passing. The results are displayed on Kubernetes, the screenshot I mentioned earlier. However, prod has no support for raw Go test or Go tools. So we built a custom test result parser, so Kubernetes can display nice results when a test fails, for example. It's way easier than going down logs and finding out what failed. Again, in the middle of 300 tests. This parser is used later in test grid, and I'm going to mention that soon. And about releases, those are periodic proud jobs, and we have right now two different kinds of release. We have nightlies. They are built against head. Basically, run all tests, they passed, build Knative, publish, tag the image with a date and a commit hash so you know where they came from, and also tag them latest. So it's pretty easy for anyone wanting to install or use the latest Knative to know what is the latest image. The same goes with the manifests. So we store them in GCS in separate directories with the same kind of tags, but now used to name directories. So you can just select that particular manifest, either latest or at a particular point in time, and you can reproduce whatever situation you want for a release. We also have the playground that is an environment that is deployed every Saturday using the latest nightly. So although every Saturday your deployments will be destroyed and vanish, at least you have the whole week to test them with Knative. The idea right now is that you have a stable and a clean environment to bake tests during the week. And to keep track of all that, we use test grid. So everything is tracked on test grid, so we know if releases failed or to build or not, and if the playground is up to date or not. So yes, let's talk about displaying results. So another screenshot of Kubernetes here showing more than just the error message. So if you click a failing test on a PR, that's what you get. A summary of your test run, what failures happened, and then your log. It's called build log, but it's whatever you did in the job. If you need, dive into it and find what happened. And this is test grid. Like the name implies, it's a grid with tests and runs. So in this case, we're seeing the coverage, code coverage grid with daily runs. And they contain the code coverage percentage. Green meaning that the code coverage is above a given threshold, and red the opposite. The white blocks mean that the test wasn't run at that particular moment. It could be because the test didn't exist at that point, or the test was deleted before that point in time, or because the run failed somehow. In this case, there's no failed run. To feed test grids, we have basically two ways. If you are talking about a pass-fail test, that's the parser, the custom Go test parser I mentioned earlier that also feeds results to Kubernetes. So test grid is able to understand that as well and display red and green blocks for all the tests you ran. And for more specific results in like the code coverage or the test latency, where you have numbers or thresholds, then we build custom XML artifacts containing the results we want to present. In this case, that will be the code coverage numbers. Okay, So given all this infrastructure, what does it do when I am creating a PR and trying to make Knative better? So I put demo in quotes because I want to risk running a real thing here. I got a few screenshots illustrating the process and what it happens. So let's start with the first step, that is creating a PR. Nothing new here. You just go to GitHub, create your pull request as usual. Then the automatic things start happening. So you create your PR, and automatically Prow will check for the reviews for your PR based on the owner file. And it's gonna add 2 reviewers to your PR. If you don't want those people to be assigned because another person is more suitable to understand or to review what you wrote, you can do it as usual in the GitHub UI. No problem here. But usually it saves you a few clicks selecting people to review your PR. And also, the pre-submit tests will start. And when they start, at some point, you're gonna get results. They can either pass, and you're gonna get all the green check marks, or something will fail, and you're gonna get a message, a post, saying, oh, this job failed, a link to the job details that will take you to Kubernetes. So again, you can inspect the logs, see what happened, work on that code until the tests are passing. And for any reason you want to rerun your tests, you can do it either each separate test, or you want to rerun the tests for whatever reason comes to your mind. And of course, there is the usual review flow. So your reviewers will add comments, you're gonna address those. Every time you add a new commit to your PR, the test will run again, and they have to be green. So nothing new here as well. And as I mentioned about the code coverage job, every time you add a new commit to your PR, the code coverage job will run and report what is the current status. So you might want to work on your tests to increase the code coverage to make sure that everything is looking good in your PR. Again, the usual flow with more input to make you more productive. And finally, at some point, your reviewers will be happy with your code. You'll be happy with your code. They will approve it, either by using the commands understood by Prow, like /lgtm and /approve, or clicking the approval button in the GitHub UI. So once you have LGTM and approval and your tests passed, your PR is ready to be merged. And Prow will notice that, and it will happily merge your PR, and it's done. All right, so that's what I had to share with you today. Thanks for your time, and I'll be gladly taking any questions you might have about my presentation.
So the question is, like for new people who start basically submitting PR, to run the test, does it require like something okay to test from a member of the organization or no?
That's correct. The question is, you start submitting PRs. Does it need any signal so your CICD system start testing the PR? Yes. I didn't mention that. It's part of Prow, but that is a safety mechanism in Prow. So only members of the organization are allowed to run the test. Why? Because you might create a PR with bad code in it to exploit the CICD system or do something bad. So if you are a collaborator that is outside the organization, you can still submit your pull request, but no pre-submit test will run until a member of the organization issues the command OK to test in the comments. It's basically a comment saying /OK-to-test. It means, hey, someone who is a member of the organization, who is a trusted person, checked that code, made sure that it's not harmful, and allowed the CI/CD system to pick up the changes and run tests with them. Yes.
So there's the pipeline. Do you eventually plan to leverage Knative to build it something?
Yeah, the question is building Knative using Knative. Yes. Yes. Right now, we're not at that point, but it seems to be a very interesting problem. Yes, and a very interesting solution. So answer yes. We're just not there yet. Yes?
In the last session, they talked about trying to make sure the different components, the serving, the build, and the eventing were kind of somewhat independent. Will that kind of move into the build process where you can independently build pieces, or will the build always cover the whole thing?
So the question is, and please correct me if I misunderstood your question. Do we have plans to build Knative as independent modules? The answer is yes. But right now, we are building as a single thing. We have plans to do that. But just like making Knative build Knative, we're not there yet. Eeny, meeny, miny, mo. Please.
You mentioned that if PR changes vendoring, it needs to be replicated to 12 other repos. Is it done automatically, or the author of the PR has to do some legwork to do that?
Okay, so the question is, test infra repo is vendored. We have to manually update all the other repos if we make change to that, or is there an automatic process? Unfortunately, we have to manually update there. So it's kind of trivial, but requires 11 rounds of approval and merging.
But I think this is a good opportunity and another piece of investment that we should do to automate that process.
Yeah, that's definitely an area that we can improve. Okay, thanks. Yes?
So before you submitting the PR, if like the change is big, is there any process like discuss question? How it should be done?
Okay, so your question is if we have any process for big PRs? No, that's pretty much dependent on the team mostly involved in the component or the process. We don't have general guidelines about big PRs, but usually people frown at too big PRs. They are hard to review, and it's pretty easy to get lost on big PRs. So probably most senior reviewers will ask the collaborator to break that PR into smaller pieces.
Maybe not big PRs, more like they change maybe something. How is that?
what kind of big change you mentioned?
Big changes. I mean, it's
I guess like a design decision needs to be something that
Okay, for design decisions, for example, there are processes in place and they are documented in the repos for Knative. So whatever goes beyond kind of changing code or implementing a feature that was already discussed, that goes to an approval process through a committee.
Yeah, so something to add on is, so for each Knative building blocks, we have a dedicated working group. So basically, every week the working group will discuss what are the new things or what are the big work items that are ongoing, and usually the design discussions happen in those weekly meetings.
so if you have changed, how would you join that?
Right, so Knative on GitHub, we have this part and list of working groups and the process of how you join them, but they are pretty open. It's just you need to join the project and then you will be joining, just starting into the meeting and you'll be part of it.
we have time.
Yeah, we have 4 minutes.
Hopefully it'll be quick. Each of the productivity working groups, obviously, you are sharing some like leveraging crowd that was built by Kubernetes. But is there, like in the Spotify model, is there sort of a chapter or a guild for these things? Because a lot of every project has similar build, deploy, release needs. They all have things to do. So there's a lot of the same plumbing being invented over and over again in every single project, plus some companies like my own. Is there a way to maybe collaborate on some of more cross-projects that come out?
Okay, so the question is, instead of reinventing the wheel every time, is there...
That's the case.
No, I understand that's a totally valid question. And every time you start a new project, you are tempted, oh, I don't like the previous process I worked with. I want to do something better, so I'm going to start from scratch. In this case, Pro is a good example. We decided to use something that is proven to work, that is well tested. It is the CICD system used by Kubernetes. So instead of creating our own, we build on top of that. And we are in constant contact with the testing SIG, the Kubernetes testing SIG, and exchanging experiences and even improving each other's products and tools and processes to make things better. Okay, so I think there are no more questions. Thanks again for your time.